Okay, so game of life is not the only thing that you can do with cellular automata. Uh, just to remind you of the paradigm, space is discrete, time is discrete, rules are local, and the update is simultaneous. But I want to do a model of forest fires. So in this model, trees grow with some random probability. We have pseudo-random number generators, random.value in Unity, that generates numbers in the range 0 to 1. If we have some probability p, 0 is impossible, 1 is certain, then with a probability of 0.8, random numbers less than 0.2, greater than 0.2 will grow 80% of the time. So we can specify at each transformation a probability of trees growing in a particular cell. If a cell has a tree in it or has trees in it, a fire has some probability of starting. And again, we do the same thing with the random number generator. And then once a fire starts, if the neighboring cells have trees, the fire can spread to them. And the fires have some set duration, and they'll die out when there are no more neighboring cells that have trees. This is a screenshot from an old Fortran program that I had. The reds are trees, the whites are fires. This is the number of fires as a function of time, and the number of trees as a function of time. And this was done in Fortran with X11 graphics. But I, of course, wanted to do this in Unity. So I'm using the fire controller meters script here. It has various arrays to keep track of things, various probabilities, whether we wrap around and whether we use diagonals, and fire duration, initial tree cover, and so forth. We're going to use a basic checkerboard with I and J cell arrays for each of these. And I'm going to be having trees, fires, and dots in each of these things. So I have two-dimensional arrays for those things. But the basic mechanics is all handled by the I cell and J cell. The trees, fires, and dots are just for display purposes. I have various sliders and texts that keep track of these different things. I catch all of them and set various values, and then set up the various arrays that I'm going to be using. The checkerboard L by L cells for the I, J, trees, fires, and dots, and an initial setup where I just kind of, using a random value, decide whether I'm going to have trees or not. And then, as with the game of life, and a subroutine iterate that takes care of things. So iterate's going to do, first of all, we have 3 states now. We have a 0 state that is no tree, no fire. We have a 1 state that is a tree, and we have a 2 state that is a fire. So instead of 0 and 1 like the game of life, we have 0, 1, and 2 as our possible states. So in the iterate, I'm going to count the trees and fires. That's for the UI's purpose. And then I'm going to scan across the checkerboard. And if the cell is 0 and there are no fires in that cell, then I'm going to randomly generate a tree, and I'm going to scan across the checkerboard. And if the cell has a 1 in it, I'm going to randomly generate a fire. I make copies of this into JCell so that I can use the update. And here I'm going to count neighbors. I'm going to look at neighbors. I'm going to check each of the neighbors to see whether the fire spreads or not. If my cell is a 2, I'm going to call neighbor IJ, and neighbor IJ is not going to count neighbors, but it's going to check to see if there are, if it's empty, it'll start a fire in that cell. If there's a tree in it, it will start a fire in that cell. And I've got a bunch of stuff for dealing with wrapping around and for doing it on diagonals and other different cases that produce different behavior. So all of that's pretty cool. Counting of the trees, just we go through and count the number of trees and the number of fires and so forth, and display that in the UI. Based on the value of the I cell, we're going to put trees there and green dots to show where they are. A bit of randomness in the position, just so that everything's not lined up perfectly. They're a little bit of random inside their little checkerboard cell. And we're instantiating trees and dots. And probably this could have benefited from object pooling, since I'm destroying and instantiating objects a lot of the time. So I've made the fires and the dots. Here's where I destroy the fires and the dots after the fire duration has occurred. And I'm going to drop a little pickup for my character to pick up after the fire has gone out, and the end of those nested loops. So let me show you that in the Fortran-like world. This is just kind of a top-down view of the dots as the fires spread and progress across the landscape. And this was about what the Fortran could do in terms of the size of things. But here it is with 200 by 200, and it's not flogging it down too terribly. We're running at basically 10 frames per second here, which is just fine. The probability of fire starting turns out to be a very sensitive parameter. That one I just did, it was 10 to the minus 3. That was the probability of a fire starting. If I reduce that probability by a factor of 10, what I get is bigger fires. The forest kind of fills in more. The fires are less likely to start. So when they do start, the forest is thick and the fires spread. And here's a case where I've reduced it by another factor of 10. So now the fires are very rare, but when they do start, the forest is very thick and they spread across the entire landscape. This is kind of what's going on in California these days. They've suppressed forest fires for a long time, and the forest is thick and full of fuel. And so when we get a fire, we get a big one. So, of course, that's not terribly interesting from the point of view of Unity. In Unity, I wanted to have trees, and I actually wanted them to grow. And so I made a little animation here for a tree that when it starts, it grows over a certain amount of time. So my trees don't just instantly appear, but they actually organically seem to kind of grow. And the rest of this is nothing more than adapting this to Unity. I've got my world here. There's a little pickup just to test. And the trees are all growing around me, and the fires are starting. And of course, fires damage you if you run through them. But when the fire goes out, we can go and pick up the little burning coins here that are left behind by the fires. Stress testing this, that was a 30 by 30 checkerboard. Here's a 50 by 50 checkerboard. We're still getting plenty of frame rate here, 70 or so, with a 50 by 50. Fires, there's a fire, big fire over here. And of course, as the fires progress, they leave clearings behind. And I actually thought this might be a feature that you could use in the game if the trees were too thick to maneuver among with colliders. Then you could maneuver among the clearings that were formed. And finally, here's an L by 100 by 100. So this is really stressing it out and we're getting down into the 20 frames per second here. Fires everywhere. So that was all pretty cool. And one of the particle effects that came with the standard assets was a fire hose. And I had the fire hose in the scene here I have the, whoops, I got to run this. I have the fire hose in the scene, and the fire hose sprays liquid around, and if you remember perhaps from playing with this example, it also pushes physical objects around with its spray. The fire hose prefab contains most of the machinery that you need to do this, since it already applies forces to rigid body objects that it hits. And there are two things that are required. One is the on-collision module of the particle system, and this has to be checked to send collision messages. It already is, since the fire hose exerts force on things. And the other is you have to set up an on-particle collision function that handles these messages. I modified the water hose particle script a little bit to do what I wanted to do here. So in the globals at the top, we have an array for collision events. And we have a private for the particle system that we're going to be playing with. And in the on-particle collision that occurs when a game object other is hit by the water, and in the case of the add force, we added a force to the rigid body to push it around with the water. Now, what I've added is another broadcast message here that I'm sending to the thing that gets hit by the particle. And I'm not requiring a receiver in case it doesn't have it. So this is going to call the script extinguish on the object other that is the fire, presumably, that I'm going to hit with my fire. Now, to turn off the fire, this extinguish script is going to have to turn off the fire. And I did make some simple modifications of the extinguish particle system script that is a standard asset on the fire object. And basically, all I did was add an extinguish function, a public extinguish function that's going to be called by that. And what it does is it goes through each of the different systems in the particle system, traversing down its hierarchy, and basically turning off the emissions so that the fire goes out, instantiating a pickup, destroying the game object, and the pickup after some amount of time. And so now I have the extinguisher. Here's an example. And I did make a whole bunch of fire hoses here so that we can, oops, there's a fire behind, oops, there's a fire I can put out. And when I put out the fire, I get a high value pickup, if I can pick up the pickup. Whereas if I don't, it's a lower value pickup, just 1 point. So it's encouraging here to go out and run through the fire and extinguish the fires, because then you have high value pickups that you can go and get after you've put out the fire. So all very fun and interesting to play with. That's yet another example of what we can do with these cellular automata. A forest fire model that has some basis in fact. I'll stop sharing here, and I'm going to stop the recording, and I'll see you all in class. Bye.